Hello there guys, and welcome back to another epic Inexorable maths video. In this video we're taking a look at reflecting graphs. So these are reflections in either the x or the y axis, okay? So obviously a reflection in the x axis would, depending on whether it's at the top or the bottom of the x axis, it would move the points like this. A reflection in the y axis, this is the y axis, every point on this side will be reflected over here, and every point over here will be reflected over here, just like that, okay? So there's some rules that will make it easier if you're given the function that is being reflected. Excuse all of this noise in the background, by the way, I don't know if you can hear it. People just bang, they just love maths, you know? Anyways, the graph of y equals minus f of x is a reflection of the graph y equals f of x in the x-axis, okay? And likewise, the graph of y equals f of minus x, notice the minus is inside the f of, that is a reflection of the graph y equals f of x in the y-axis, okay? So like a sort of exam question that you could be asked is something like this. It tells you what f of x is. F of x is x minus 2 times x plus 2 times x. Sketch y equals minus f of x. Okay, so the strategy here, I would say, is I would probably say either, if you know what f of x is, then minus f of x is just negative all of this. So you could just make this negative. Or you can sketch f of x, and then you can reflect it in the x-axis, because this is minus f of x. Minus f of x is a reflection in the x-axis. You can do it that way. So there's numerous ways to do it. Because I've got two graphs here, let's actually sketch f of x, y equals f of x, and then let's sketch y equals minus f of x, and we can actually see how they work. So to sketch y equals f of x, just the normal f of x, how do we do it? First of all, we need to find the y-intercept, okay? So looking at this, you can either expand out this f of x to get it in the form because this is obviously a cubic, isn't it? Because there's 1, 2, 3 x's multiplying together one way or another, which means we are looking at a cubic here. So we can get it in the form y equals ax cubed plus bx squared plus cx plus d. Or we can just evaluate it just by inspection, and we can say, well, there's clearly not going to be a constant in this at all. If we were to expand all of this out, there wouldn't be a d term. The reason for that is because if you imagine expanding out this bracket and then this bracket, that could have a d in it, but then it's being multiplied by x, which means there's no way on earth that we've got a d term in this, which means that d is 0. Which means, because d is the y-intercept of a cubic, the y-intercept is 0, which means 1 point on the graph is 0, 0. So this is the graph of y equals fx, 0, 0 is on the line, okay. Now we can take a look at finding the roots, the x-intercepts. How do we do that? Well, where should we even do it? There's some room at the bottom somewhere. Excuse me, there's a big box. Okay, let's sort of just do it down here. We don't need to take up too much space. If this is y equals f of x, we can say that y is equal to x minus 2 times x plus 2 times x, like that. But guys, when we're on the x-axis, what's equal to 0? Of course, like always, it's y. So we're going to say that 0 equals x minus 2, that is a 2, looks like a squared, big 2. 0 is x minus 2 times x plus 1 times x. So all we need to do now is, just like in many other videos, recognize that either for this expression to be true, either this bracket is 0, this one is 0, or this one is 0. So how do we make any of these brackets 0? Well, what are the values? X can either be, if this was a 2, this would be 2 minus 2. So we get x is 2. We also get minus 2, because minus 2 plus 2 is also 0. So x can be minus 2. And of course, x can just be 0. If x was 0, put a 0 there, x is 0. Or y is 0 rather. So x and y is 0. But we actually already know that. When y is 0, x is 0, that's that point there. Beautiful. So there's only 2 more points. There's positive and negative 2. So we'll say positive 2 is about here, and negative 2 is about here. And then we just need to look, is the graph just f of x, not minus f of x, just f of x, is that graph positive or negative? Okay. We're just looking at it. The a term, the ax cubed, is clearly 1 because x, there's no constants in there. It's x times x times x. So the a term is 1, means it's positive, so it's a positive cubic, which means it's going to start coming up and it's going to end going up. So we just link these together in the only possible way with the knowledge that it has to start by coming up. So we literally just go up, down, up, like that. Boom. This is the graph. Y equals f of x, baby. Done. Now, we know that y equals minus f of x is a reflection of this graph in the x-axis, okay? Basically means if you put a mirror here, that's where we're reflecting from. So we just need to basically swap all of the x coordinates, or not x coordinates, I guess, just basically we need to sort of do it like that. So how do we do it? Just look at it. Like you've still got, because this is the point, let's label them actually, just to make things easier. That's 0, 0, that's 2, 0, and that is actually supposed to be going through, but as we know by now, guys, my drawing skill is awful. That is the point minus 2, 0. So if we flip this round, are the x coordinates on the x-axis, are they going to change? No. So we can still plot negative 2, positive 2, 0. They will not change. They will change if you reflect about the y-axis, not the x-axis. And then all we need to do is just look at it and decide, okay, well this time it's going to be going down and it's going to finish coming down, isn't it? Because it's reflected. You just have to kind of look at it. So we're going to come down, we're going to come up, and we're going to come down. Once again, I've managed to miss. I don't know how, like, I miss so much. Jeez. Okay, that is minus 2, 0, 0, 0, 2, 0. This is the graph of y equals negative f of x. Not y equals f of negative x, y equals negative f of x, okay? Boom. Can you guys see how this is clearly, I should say this, is clearly a reflection across this line of this? Every point, like let's say you have a point here, whatever this point is doesn't really matter, it's been put up here. This point has been put down here. But we've just done that with an infinite number of points which make up this line, this continuous cubic function. That's it, that's all you have to do. So obviously the other way that you could have done this is you could have said, okay, I know what f of x is. To sketch y equals minus f of x, just sketch this. How do you do that? Well, that's a minus 1, and you could say that's an x minus 2, so I can actually just cancel the minus 1 out, and I can make this negative. So if you guys catch my drift, instead of x minus 2, I could write 2 minus x, because 2 minus x is x minus 2 multiplied by minus 1. So this minus 1 disappears and it just goes into here. And then you just sketch that. And this graph, I will put it up on Desmo's, this graph is that. Same thing. Okay guys, so I've got another example here. This is something that you need to watch out for. Some functions are kind of symmetrical in a way. So I'm going to show you what I mean by this. This time we're looking at y equals f of minus x, not y equals minus f of x like the last one. This is now f of minus x, which as we can see here, f of minus x is a reflection in the y-axis, so it's going to be a different reflection. But something really weird happens when we have a function like y equals x squared or f of x equals x squared. So I'll show you what I mean. If I'm not going to use a ruler this time. If we want to sketch y equals f of x, this is not the reflection, this is just f of x. This is y equals x squared, right? Again, we should know what this looks like. It's a sort of like U shape, just like that. That's x, that's y. And it touches 0, skims the x-axis at 0, 0. I won't even put it in. 0, 0 is the intersection. We should know that like the back of our hand. Something really weird happens though. About this line of symmetry on the y-axis, just like this, what happens? It's symmetrical. It's literally symmetrical about the y-axis, which means, I'll just tell you now, if you sketch y equals f of minus x, it is the same graph. This is the graph y equals f of x equals f of minus x. They are the same graph. I hope you can see that, you know. Like imagine just getting a mirror and reflecting it and looking into that mirror from this side, it would just show you the normal curve. It doesn't change anything. Now, if you reflect it about the x-axis, it will change because it will come down like this, will change. But if you don't, nice. There's some functions that just do that. Now, these functions actually do have a name. These, like a function like this, which is symmetrical about the y-axis, is called an even function. That comes from a very miraculous, very strange thing called a Taylor or a Maclaurin series. You don't need to worry about it. But just if you want, just curious, this graph, y equals x squared, it is even. If you know anything about trigonometry, the graph of y equals cos x or cosine of x is also an even function because it is symmetrical. Don't worry, we haven't done trigonometry yet. Sine x is an odd function because it is not symmetrical. So you have graphs that kind of do that, and that's absolutely fine. So yeah, just something to look out for. You can get this. You might be in an exam like, what's going on? Totally normal, can happen. It's just clearly symmetrical about the y-axis. So that's called an even function, okay? So guys, every question is exactly like this. If you have, just sort of remember this. If you're not able to remember it for some reason, like, just try. Or plot points and just see what it looks like. Like, if you just plot f of x, but just make the whole thing negative like this, like, yeah, it's going to be a reflection of the x-axis. If you plot f of x, but change every time you see an x with a minus x, yeah, it's going to be a reflection of the y-axis. Another thing, the reason why this graph is symmetrical, by the way, is because what is f of minus x? It's minus x squared. There we go. Minus x squared. Because every time you see an x, you need to replace it with a negative x. That is a negative x. What is negative x squared? X squared, which means it doesn't actually change the graph, okay? So that's the reasoning behind it. Anyways, guys, as I say, every single question like this is basically exactly the same. You just need to know this, okay? So thank you guys very much for watching. I highly appreciate it. And I will see you in the next video where we're probably going to be looking at straight lines. See you guys in the next one.